Hey guys, welcome back to Learn Python the Hard Way. Today we're going to focus on inheritance and composition, what they are and when to use them. And as always, you can find the link to the current exercise in the description below. This is part of the paid section of the book, so you would need to purchase the book, or alternatively, of course, feel free to follow along with the video. So in the previous exercise, we already learned about working with classes and also how we can create subclasses and parent classes. And today we're going to focus a little bit deeper on inheritance and how to properly work with inheritance. And when working with inheritance, we can either inherit from a single class, or we can use what's called multiple inheritance to inherit from multiple parent classes. And that can be very tricky and can cause a lot of different problems, and therefore it's really important to not to use that properly. So let's start out by actually defining what inheritance is. So inheritance is used to indicate that one class that we are working with will get most or all of its features from a parent class that we defined. And that can either happen implicitly whenever we write, for example, class foo bar, which basically says we make a new class foo, which inherits from the parent class bar. So, and when we use inheritance, we have basically three kinds of different specialization that we can use. So first of all, the actions on the child basically imply an action on the parent. The actions on the child override the actions of the parent. So that means we basically override a functionality that has already been defined in the parent class. And third, the actions on the child alter the actions on the parent. Meaning basically we take some of the capabilities that have already been defined in the parent class and then making some adjustments to it. So let's take a look at each of these three cases. So the first one is implicit inheritance, which is the first case here. So the actions of the child imply an action on the parent. And for that we have a short example here where we define a class parent with a function or method implicit, which is just a print statement. And then we create a subclass called child, which inherits from the parent class, and here we just pass in pass, which basically just means that we don't do anything within the child class. After that, we instantiate the parent class here, creating a new object called dad, and we do the same for a new object called son, which is an instance of the child class. And now we can call implicit, the function or method defined in the parent class, on both the dad object and the son object. Even though if you take a look at son, which is an instance of the child class, we actually never defined that function, that method, inside of the child class. That's automatically inherited from the parent class. And that's basically the implicit inheritance. That means we didn't explicitly state that we want to use that functionality within the child class here. It automatically gets inherited from the parent class. And to train that better, let's switch over to our code editor and actually let's type out that piece of code here. So as always, we can open our terminal window and then open a new code file. I'm using Visual Studio Code, therefore I'm typing out code followed by the name of the Python file that I want to create. And I already wrote out the code before, but I highly encourage you to also type it out just to build up some muscle memory. So here we define the parent class with the implicit method, which prints out this print statement. And then we have a child class which inherits from the parent class, which doesn't do anything. We just put in path here because within the class definition we definitely need to provide some block of code. So path here just basically does nothing, but is still required. Then we instantiate those two objects here, and then we call implicit on both the parent object and the child object here. Now let's run the code by again switching over to our terminal, typing Python followed by the name of the code file. And now we can see we print out parent implicit twice, once directly here called on the parent object, and then the other time we are calling or printing that line here by calling implicit from the child object here. And since we are using implicit inheritance, that is possible since we automatically inherit all the functions and all the capabilities from the parent class. So that's basically the first way of doing this. The second option here is to explicitly override capabilities of the parent class. So if we take a look at that example here, we can see we again have a parent class, which is a parent class here, and then the child class, which is a subclass inheriting from the parent class here. And in contrast to the first example we looked at, here we actually have code included in both the parent class and the child class. We have a function or method in here called override, and that prints out a statement. So here in the parent class, we again have the print statement parent override within the parent. But now within the child class, we don't just put pass in here to automatically inherit the functionalities from the parent class, but instead we add a separate function here which has the exact same name as the method in the parent class. So we also call it override, and this actually overrides the capabilities of the parent class. And of course, it doesn't have to be called override. It could be any name. For example, if we call it hello, we would simply need to use the same name in both the parent class and the child class, and then we can specify the functionalities that should be executed within the child class. So here the change is minor but still important. We print out child override instead of parent override, and therefore we basically override, we change what happens when we call the override method here. So that's the way of explicitly overriding the capabilities provided by a parent class. So let's switch again over to our code editor and create or open a separate Python file for that. And here we have the example of using the explicit override by creating a different method in both the parent and the child class, and again using the same name for both. So let's run the code here. And now we see when we instantiate the parent object here called dad and the child object called son, and we call the same the method by the same name, override, we get back parent override for the parent object here, and we get back child override for the subclass here, because of course we overrode that particular method. So that's the second way how we can use inheritance. And then we have, of course, a third way of doing this. This is basically using a combination of what we've seen so far to basically taking the behavior of the parent class and making some changes to it. So here's an example. Again, we have a parent class and we have a child class, and here our class child is a subclass that inherits from a parent again. And within the parent class, we have a function or method called altered, which prints out parent altered. And then within the child class here, we first of all have again a function called altered. So similar to the example we saw before, we would basically override the capability that is provided by the parent class. But we're making actually a subtle change here, which allows us to still use behavior of the parent class, but make changes to it. So first of all, we add a print statement in here. So child before parent altered is the first print statement. And then that's important here, we are using a method called super, which is a special keyword. that allows us to access the capability of the parent class. And what we pass in here are two arguments. First of all, child, which is the name of the class which we're currently in. And then, of course, we always have to use self since we are inside of the class. And now, when we pass in child and self to a super method here, we automatically get back the superclass of the current child class that we have here. So we get back the parent object here, the parent class. And on that parent class, we then call altered. So in this case here, we basically execute the original altered class, which prints out parent altered. And then finally, we have another print statement here, which we added in the child class, so print child after parent altered. And that allows us to actually use the original capability that was provided by the parent class by using again the keyword super. But we also add our own twist to it, basically adding those two print statements to it. And again, if we didn't define altered at all, then we basically automatically would have that behavior that super provides here, so we automatically get all the capabilities of the parent class. So that's a way how we can use some of the behavior of the parent class and then make some adjustments to it. So let's again switch over to our code editor, and I would recommend to create a new Python file just to type out that code to build up the muscle memory. And now if we write out that code as specified here, and then we instantiate again a dad object here, which is an instance of the parent class, and then the son object, which is an instance of the child class, and we call again altered, the same name, both on dad and son. We get the following back. Let's just execute our code here. So first of all, since we call dad.altered, we execute the following print statement: parent altered, which is the first line here, and then the next 3 lines of code are actually executed because we call altered on the child class and the subclass. So here we first of all, of course, just as we've seen in the previous example, would print out child, or the statement we find in here, which we have overwritten basically. So child before parent altered, but now we have that special case of using super, executing the method here in the parent class. So again, we print out parent altered, and then finally we print out child after parent altered as a final statement. So that's the third way of how we can use inheritance, by actually making some changes to the functionality provided by the parent class. And again, that's described here in detail. So important are the lines 9 to 11. We are first of all just executing the print statement here, which is defined in the child class. Then we call super, passing in child and self, and calling altered, the altered method of the parent class on it. And then again, finally, we are using the print statement again to execute that. And of course, we can combine those 3 approaches we learned about. Here's a final example of inheritance where we're using all 3 cases: implicit inheritance, explicit inheritance, and then of course how we can alter the behavior provided by a parent class. So in this example here, we have a parent class again, and we have a child class which inherits from the parent class. Just as in the previous examples, we define override, implicit, and altered, which are the 3 examples, the 3 actions we learned about. And here in the child class, when we first of all, of course, can use the implicit functionality here, we can, when we instantiate an object from the child class here, we can call implicit on that object, even though we never defined it within the child class itself, because we automatically get access to it since we inherit from the parent class, which provides that capability. Then we can override the capability. So here we just provide a completely separate print statement, completely separate capability. And then of course we have the third option that we saw before. By using super, we can access the capability, the functionality provided in the parent class. And then of course we can make any changes around that super keyword. So here we are adding a print statement before and after, just as in the previous example. And after that, of course, we simply create our objects here by instantiating those objects based on those classes, this parent class and the child class. And then we can call those methods on it. And let's again type this out, which I did ahead of time. And if we then again execute that from our terminal, we can see the following output. First of all, of course, we are calling that, so which is a instance of the object instantiated from the parent class. We call implicit on it. So implicit is only defined in the parent class, and it executes the print statement here, parent implicit. We call that implicit method on both dad and son, even though it's only defined on the parent object, and we get back parent implicit for the call on the parent object, and also we get the same back for the child object, because of course we implicitly inherit that. Next we are calling the override method, again on the parent and on the child object. And here for the parent we have parent override, which we get back, and then for the child class we have overwritten that functionality by changing it to child override, which is of course what we get back when we execute that on the child class, on the object of the instantiated based on the child class. And then finally we have that altered behavior here, that altered method. So on the parent class here we defined parent altered, which is printed here, and then within the subclass here, the child class, we print out child before parent altered. We use the super call again to call the method defined in the parent object, which is parent altered, and then we have another print statement here defined within the child object. So that's how we can use all three approaches in a single program. So let's take a closer look now at the super keyword we saw before, and why we are actually using it. So I mentioned initially that instead of just inheriting from a single class, what we have seen in the examples so far, where we inherit within our subclass from a single parent class. So here, for example, child is a subclass of parent. What we can also do is we can use multiple inheritance, which means we can inherit from multiple parent classes. So here, for example, we define a class called Superfun, which would inherit from both child and bad stuff. And multiple inheritance can get quite complex, because we basically get access to the methods and functionalities defined in all of the classes we inherit from. And that of course can be quite complicated, can get quite complex to understand what's actually going on. So here we make a class named Superfun that inherits from both the classes child and bad stuff at the same time. So in this case, whenever we have an implicit action, so an action, a method for instance, that's being inherited from any of those parent classes, then Python has to actually look up possible functions in the class hierarchy for both parent classes, in this case for both the child and the bad stuff class. Because of course we could have defined a functional method in either one of those two parent classes, so that gets a little bit more complex in terms of looking that up. And also Python needs to make sure that it does that in a consistent order. So for example, if we had the same function defined in both child and bad stuff, so if we have, for example, our implicit function that we saw before, implicit method that we saw before, and we are defining that in both child and bad stuff, and we inherit now this capability to Superfun, then of course Python needs to know which one we actually want to use if we create an object based on superfun, and we call that implicit method. Now, which one should be used, the one defined in child or the one defined in bad stuff? And in order to figure that out, Python uses the method resolution order, MRO, and also an algorithm called C3 to get that straight. And this method resolution order is quite complex and uses a well-defined algorithm, and therefore Python can't leave it to us to get the MRO right, but it would do that implicitly. And the way it does that is by using the super function that we saw before. And that handles all of this for us and basically executes the correct actions like we saw before with child.altered. So with super we don't have to worry about that, but Python basically does that behind the scenes. And one typical use case that's often used is using super with the init method. So that's actually the most common use cases of super to use within the init function in the base class. So this is usually the only place where we need to do some things in a child and then complete the initialization in the parent. So here's a quick example. We have a child class again, which inherits from a parent class. And here we define our init method, which of course is called automatically when we initialize a new object created from that child class. Here's an instance of that child class. So here we are defining the init method, which takes two arguments, self and stuff. We assign stuff to it, so here that would of course be assigned to self.stuff. And then after that we are using super to actually access the init method of the parent class. So here have the class called parent. And again we pass the two arguments child, which is the name of the class, and self to the superclass to get access to the respective superclass, which is parent in this case, and then we call init on it. So that's how a typical use case of how you would use super. Now, so far we have looked at inheritance and the three different ways of how we can basically use inheritance using implicit, explicit, and an altered way of using inheritance. There's another way of basically getting access to functionalities defined in another class by using what is called composition. So while inheritance is useful, another way to basically do the exact same thing is to use other classes and modules rather than to imply or to rely on implicit inheritance. So far, if we looked at the three ways of using inheritance, two of the three ways of doing that required that we wrote new code. Only the implicit inheritance basically meant that we didn't have to write any new capabilities and any new code in the child class. And that can be easily replicated by just calling functions in a module. So here's an example. Now we have again two classes. One class called other, which is a main class, and then we have the class child, which again is a child class of that, which is not a child class. So in this case, those are both actually main classes which do not inherit from each other. And within the other class, we have three different functions or methods called override, implicit, and altered. And now instead of using inheritance, what we do is within the child class here, we actually use the init method. And by creating a new object of that child class, we then automatically instantiate an object using the other class that we have up here. And then we can simply use that object that we created by using self.other and then calling the different methods defined here in the other class. So we can call self.other.implicit, which is defined up here. We can, for example, also call self.other.altered to get access to the other method. So that's a different way of basically achieving a very similar result to inheriting functionalities from one class to another one. So let's again type out the code here. And if we take a look at that, here at the bottom, we then instantiated a new object from the child class here called son, and then we call implicit, override, and altered, so the three different actions of inheritance that we learned about, using composition this time to actually basically achieve something very similar to inheritance. So if we call son.implicit, we can see that we have now the implicit method in here in the child class, which we didn't have to do in the case where we used inheritance, because of course those functions were inherited automatically. So what we needed to do is, of course, first of all, to instantiate the other object here using init, and then adding one additional method using here implicit, and then calling the implicit method. But the other two cases, override and altered, are quite similar. So in the case of override, we of course simply provided some other capabilities here. So in this case we printed child override, whereas in other we would have other override. And then taking a look at altered, we now are not using the super method because of course we did not inherit from the other class. Instead we are simply calling self.other, which again refers to the object we created based on the other class, and we calling altered on it, which of course is the method defined here in the other class. But if we execute our code here, we can see that the result is very similar, or actually identical, to what we have seen before using inheritance. So again, we get back other implicit, which is basically what's defined here. We get back child override, which basically means we overrode. Well, actually we didn't, but if we had used inheritance, we would have overwritten the capability of the parent class here to print out child override. And then finally, of course, we used an altered way of printing out those 3 lines, not using super, but getting a very similar outcome. And important to mention here, we learned in some of the previous exercises that there are 2 different kinds of relationships, either an is-a relationship, which is that kind of hierarchical relationship which we are using when we're using inheritance, which we saw in the previous cases. In this case, this is not an is-a relationship because we are not inheriting capabilities. Instead, this is a has-a relationship because here the child has a other class it's working with. And of course, we get basically the same output as before using composition as opposed to inheritance. And of course, what we could also have done is, especially if we want to use the functions and methods that we defined in the other class often, then we could have created a module called, for example, other.py, and then basically used that and imported that in all the pieces of code that we are working with it. So now we learned those 2 approaches and how composition is actually can be used in quite a similar way to inheritance. Of course, the big question now is when to actually use inheritance or composition. When is one better than the other? And that really comes down to us trying to solve the problem of reusing code. So we don't want to have duplicated code all over our code files that we're working with, because that's neither clean nor efficient. And inheritance basically solves that problem by creating a mechanism for us to have implied features in base classes. So we use that implicit inheritance to automatically get access to the methods defined in the parent class. And composition takes a different route. It solves this by giving us modules and the capability to call functions in other classes. And we could, for example, then import those modules to get access in our code files. So in both solutions, inheritance and composition, we solve the problem of reusing code. But then, of course, the question is which one is more appropriate and when should we use which. And that's somewhat subjective, and there's not always a clear answer for that, but there are some guidelines which we can use. The first one is to avoid multiple inheritance at all cost, as it can be very complex, or it can be too complex to be reliable. So if we go back up again and we take a look at this example here, that was an example of multiple inheritance, where in this case we inherited from 2 parent classes, and of course we could have more classes than that, and that can get very complex and can cause a lot of issues. So if, however, we are stuck with it and there's no way around using multiple inheritance, then we should be prepared to know the class hierarchy and really spend the time to find out where everything is coming from, where which methods are defined, and what the behavior is. But if there's a way around it, then we should not use multiple inheritance, and there are actually other programming languages which don't even support that concept, because it can lead to errors that can be quite difficult to debug. The second guideline is to use composition to package code into modules that are used in many different unrelated places and situations. So we can basically use it to create sort of a toolkit and then to reuse that in different places. As an example, if we have, for example, some math functionalities that we want to use in a lot of different pieces of code that we're working with, then we could, for example, create a math module and then simply import that whenever we need it. We should use inheritance only when we have a clear relationship, hierarchical relationship between reusable pieces of code that fit under a single common concept, or if it's something we are using. So if we clearly say this is related in a is-a relationship, then inheritance is the right solution to choose. But of course we need to be somewhat pragmatic. We can't be a slave to these rules. We need to remember that the entire concept of object-oriented programming is an entirely social-based convention that programmers created to create packages and share code, and therefore, since it's not codified, and therefore we have to make sure that we are not forcing ourselves, but that we are using the right tool, and we are somewhat pragmatic about that. So that's the difference between inheritance and composition, and some guidelines that can guide us in choosing which approach to take. We finally have a study tool here, and this one is a little bit different from the ones we looked at before. Specifically, it's quite a big exercise, and the exercise specifically is to take a look at PEP8, which is the style guide used by Python, and then to understand what the recommended ways of writing code are. And important to mention, the exercises we have done so far and also some of the upcoming exercises don't always strictly adhere to the PEP8 style guide, but we should generally always make sure that we adhere to it. And that's especially important when we work with other programmers, just to ensure that we have a similar way of writing code. I'm also going to include the link to this exercise here, to that style guide, in the description below. And if we take a look at that and we switch over to the Python website, we can see here the PEP8 official style guide for Python code. And this was actually created by the creator of Python, so it's quite official and we should generally adhere to it. Important to mention, we can of course still write code which does not follow the guidelines defined in PEP8, and our code will still work, but especially when we work with other developers, it definitely makes sense to stick to it, just to make it easier to collaborate and to have, for example, the same way of indenting code and working with it. So here, just to take a quick look, we have the table of contents, which for example includes a quick introduction and then different guidelines regarding the style. For example, here regarding the code layout, what the indentation is, whether to use tabs or spaces, how long the maximum line length should be, but also covering other aspects, so for example comments, and also naming conventions. And if we just scroll down a little bit here, we can see that if we take a look at indentation, we see that PEP8 requires that we use 4 spaces per indentation level, so we would not be using tabs but spaces, and 4 spaces specifically that can be set up in our code editor, that if we press tab, for example, we automatically indent by 4 spaces. And that's of course quite important, especially when we work with other developers, because if developer A, for example, uses only 2 spaces and developer B uses 4 spaces, and then we want to work together with our code, it can actually cause errors because the indentation level would not be the same. So that's quite important to keep in mind. And here there's always a quick example of how to properly use that with the right indentation, the correct case. Here, for example, is the 4 spaces, and then a wrong case with the wrong indentation. So that can be quite helpful to take a look at that. And there are a lot of those guidelines. And of course, since there are a lot of recommendations here, we don't necessarily have to remember all of them. There are a number of different plugins that we can install with our code editor, and then it will automatically notify us if we violate the PEP 8 style guide. And that's a good way to just ensure that we follow the recommended guideline. Let's finally take a look at some common student questions. The first one is, how do I get better at solving problems that I haven't seen before? And really the only way to get better at solving problems is to solve as many problems as we can by ourselves, by actually thinking through the problem and approaching it ourselves. So typically people had a difficult problem and then they rush out to find an answer, and that's fine when we are under strict time constraints. But if we have the time to actually solve it ourselves, then we should take the time, because that's the best way to actually learn how to address those kind of problems and how to consistently learn how to really resolve and solve problems ourselves. Aren't objects just copies of classes? So there are some programming languages like JavaScript, for example, where that's indeed the case. These are called prototype languages. And there are not many differences between objects and classes other than the usage. However, in Python it's different. Here classes act as templates that mint new objects, similar to how coins were minted using a die, a template here. So that basically means the class is basically the blueprint or the factory that we're using, and then the object is the actual instance that we are working from. So we can create a number of different objects using the same class, for example. So that's it for exercise 44, and see you guys in the next video with the next exercise.